Hi there, welcome back to the channel, and today I would like to introduce to you the concept of what we like to call the voltage divider, okay? So let's just start by drawing the circuit so we can see what it actually is, okay? So we have a supply rail, let's call this V in, because this will act as the input voltage. We have one resistor here, let's call this R1, and we have another resistor in series. Let's call this R2. And we have a ground connection here. So in the middle of these two resistors, we take a wire here, and this is the output voltage. Okay, that's all there is to a voltage divider circuit. It's just two resistors. Okay, but let's do an analysis to see why we call it the voltage divider. Okay. So we have an output here, which is the current across the second resistor. So we can say that V out equals the total current multiplied by the second resistor, R2, just like that. But we have the total current here, which is also equal to V in divided by the total resistance. Okay? Because the total voltage divided by the total resistance will therefore give us the total current. And that's what we need. So we can write it again like this. Okay? And we can rewrite this one more time, which will help you perhaps understand this a bit clearer. Okay, same thing, different style, right? So the reason I write it out like this is to show us that the ratio of the resistors that we choose here determines a fraction of the input voltage, which will give us the output voltage, hence the voltage divider. We take a fraction of the input voltage according to the ratio of the resistors that we choose. That's all there is to a voltage divider. The analysis is that simple, okay? So just keep that in mind, and I'll just have a couple of questions for you to maybe test your understanding of the voltage divider from an engineering point of view. Okay, so here I have a couple of questions for you to have a go. So given that V in is 12 volts and V out is 8 volts, choose realistic resistor values for the voltage divider circuit that verifies this statement to be true. Okay? And question 2, could you state any possible advantages or disadvantages of the design of the voltage divider circuit? Okay? And I've been nice, I've even given you a nice drawing here of the voltage divider circuit. Like it's really turned around today. Alright, so have a go at those, and I'll just run through some answers with you in just a second. Okay, so let's now start by discussing the answer to question 1. So let's remind ourselves the fact that what we want to be true is that V in is 12 volts and V out is 8 volts. So let's put that in terms of mathematical equations like we saw just now, that 8 equals 12 multiplied by the fraction of the resistors, like previously discussed. So by looking at this, we want this fraction here to be equal to 2/3. So how could we do that? We could set R1 equal to, realistically, I would say 1 kilo ohm, and R2 equal to 2 kilo ohms. So by realistic, just choose a realistic order of values. Of course, depending on the situation where you're trying to use the voltage divider, but more times often than not, this is what you want. You want 1 kilo ohm and 2 kilo ohms, not 2 ohms and 1 ohm. There will be a lot of heat, your resistors will burn, and you might get some funny looks, okay? So just keep it professional, like that. So now let's discuss question 2. And let's start by discussing some advantages of the voltage divider circuit design. So one of them I can say straight away is that very simple design. Because it's just 2 resistors in series. That's all there is to a voltage divider. Another advantage, cheap cost. Again, we're talking 2 resistors here, nothing fancy, no MOSFETs, no IGBT transistors, just 2 resistors in series. That's it. And one more advantage I could say is that it saves space. Compared to other, let's say power converters out there that can do a similar job to this will save a lot of space. Just 2 resistors in series. I know I've said it a few times now, but it's true. It saves a lot of space. So now let's discuss some disadvantages. The accuracy is not always going to be great for a voltage divider, because that depends on the resistor tolerance. They all have them. If you look at the bands on the resistors, and you could find a poster online that will tell you what each color means and for what band. But yeah, that's what I'm trying to say, is that it depends on the tolerance, the accuracy. As well as the temperature. The temperature can also have a role in affecting the resistance of the resistor, but it's generally, more times often than not, once again, it's kind of, you can forget that. But it's something that you should be aware of. And because we're using resistors, not anything else, the power is dissipated as heat. Now this one might not be so unavoidable, but it's something you should be aware of once again, because you could have some potential cooling problems if you have designed one of these things. And one more disadvantage I would say is that there are power losses in the voltage divider circuit. Because if we take a step back to the basics, I think we should know that in a series resistor, the voltage will drop. And we can't get that back once we go past the resistor. So, of course, a voltage divider, let me just draw it one more time. V in is here, V out is here, and the ground is here. So once we go past R1, and we're across R2, we're past R1. So we're going to lose some voltage across R1, and power is a product of the voltage and the current. So that will take a dip according to the drop of the resistor. So that's all I would have to say about question 2. Of course, there are more advantages and disadvantages out there that I, of course, haven't discussed yet, but I would be happy to discuss them. If you have any questions, I would be happy to answer them in the comment section of this video. Okay, so that's all I have to say today on the voltage divider in this video. Thank you very much for watching.